Okay, so layer 3 EVPN. So as we during the start of this EVPN session, we discussed this topology, if you guys remember, right? So basically you can consider that this is the PE devices, PE1 and PE2 devices, and in between it's a, so basically this is service provider network, right? And on PE devices we have different customers connected, right? So here we have different customers connected in different WAF. Let's say this is customer A and B, right? And both customer want to advertise same prefixes to the other side of the network, right? So if let's say this is our BLR and the other side is HQ, right? And they want to communicate between these two sides. What they have to advertise this public private IP address to the other side, right? So that they basically they should have reachability. So what we are going to do is basically they will advertise that to the PE device. This route will be in this particular WAF. It will be installed in this particular WAF for 10.1.00. And then it will be advertised type 5 route, which will first come into EVPN route, global EVPN routing table. And from that type 5 route will be advertised to PE1 based on route distinguisher and RT route target. It will understand that I have to install this route into this customer AWAF. So that will be installed there, and from there again it will be advertised back to the customer, right? So this is how basically this will work, right? What we are going to use is type 5 route, right? Type EVPN type 5 route updates to advertise this prefixes, right? Uh, any question on this? Anyone has any question? Okay. So basically this is how the configuration looks like under BGP, right? Under router BGP, you will create two different WAF and RD and RT value for both that WAF, different separate RD and RT values, right? This is more, if you remember, we discussed, right? If it's a complex scenario where you want to advertise some other prefixes also, from basically ISP wants to advertise to the customer, right? So yeah, that are different variants. Basically complexity we can basically customer can use. So this is how it looks like if you look at the logical perspective. So you can consider that this is one customer, another customer CE2. Basically there are three different customer locations, CE1, 2 and 3, right? Or branches you can say, and they are connected to the VTAP devices. You can consider this as a VTAP, right, in DC environment, or you can consider this as a P in a service provider environment, right? So basically what you are doing is this 200.2/24 subnet, right? You will advertise to the VTAP, right? This VTAP pair. So basically through eBGP. So you can use anything here, but generally, with service provider, it is what eBGP is supported, basically used. So you advertise this specific route 200.2 through eBGP to this VTAP. VTAP will learn this eBGP route, this route, and it generates type 5 route, right? It generates type 5 route, EVPN type 5 route, and then advertise that route to another VTAP pair, right? That route now will be installed in EVPN route, and from there, based on route target, right, it will be installed into the particular WAF, right? In this case, green, tenant green, and from there it will be again advertised to the peers, right? EBGP peers, so that this guy knows how to reach 200.2 subnet, right? /24 subnet, right? And then they can forward the traffic. So yeah, this is how this is used, L3 EVPN. Anyone has any question if you have not understood?
Ishan, do we need to enable MPLS in the uh, uh, network, or it's not required?
Yeah. So basically for data plane, okay. So for control plane, right? Control plane, what we will use is EVPN, right? Control plane. So basically to advertise these routes, right? From this route to this guy and this route to other VTAP pairs, what we use is EVPN in this case, right? EVPN. So basically this is nothing but L3 VPN, right? We are advertising L3 routes. We can use either EVPN or we can also use L2, L3 VPN, basically MPLS V4, right? That also we can use, right? VPN V4, basically VPN V4. So that also we can use. So let's say in this scenario, we are using EVPN. Now data plane, right? Data plane can be either VXLAN, data plane can be either VXLAN or MPLS, right? So depending on where we are implementing this L3 VPN. If we are implementing this in DC, right, data center, then we will use VXLAN as a data plane, right? And if this same EVPN we are using in service provider, then we will use, basically they will use MPLS as underlay, right? Data plane. Okay. So basically, yeah, data plane is VXLAN or MPLS, right? Depending on where you are, you are using this. So for DC, generally people they use VXLAN, and for service provider they use MPLS as a data plane. Is it clear?
Yeah, thanks.
Okay. Any other questions? Okay. So yep. So if we go more, if we consider two different WRF, right? So let's say green WRF and blue WRF, right? And these are the VTAP. So these are one VTAP, VTAP 2 pair, and VTAP 3 pair, right? So we have three different VTAP pair. These are the spines, right? Now let's consider that we have two different WRF, right? So basically what you will do on this VTAP is you will configure two different WRF, right? Green WRF and blue WRF on all these VTAPs. Now under this VTAP, you have one subnet, right? 10.10.1.0 and 2.0. This is independent subnet, right? So all the host behind this VTAP in green WRF has this range, this subnet. Host has this subnet. Similarly for blue also this subnet. Okay. On another VTAP, there are different subnet for the host is different in green and blue. It's a 3.0 and 4.0. And here it's 5 and 6.0, right? So basically each VTAP has different subnets, right? It's not overlapping. This subnet 10.10.1.0 host is not here. They have individual subnet, right? So what we will do is basically you will have SVI configured for both of these subnets, right? So you will have SVI configured for 10.10.1.0 and 10.10.2.0, right? So basically what we will do is we have redistribute connected under WRF, right? WRF 10 and green, right? Green. This is again under router BGP, right? So under router BGP, we have WRF green, and we configure route distinguisher and route target, right? And we also configure redistribute connected, right? Redistribute connected. So basically what will happen, these two are directly connected routes. So these two routes will be redistributed into EVPN, right? So we will generate type 5 route for both of this, right? Type 5 route will be generated. And that will be advertised through VTAP to all the other VTAPs, right? And similarly for this side also, all other VTAP will also advertise their own subnets, local subnets, type 5 route with this route distinguisher and RT value, route target value, right? Which is unique. Let's say here it is 10:10. Then for blue, it will be 11:11, right? Separate. So when you receive this route, type 5 route here, you look at it will be in first installed or received into EVPN table, right? Global EVPN table. It's a global EVPN table because it has all the routes from all, for all the WAF, right? So and that will be differentiated by route target value, right? So it will have all the routes. Depending on route target value, you will decide that, hey, I have to push this route into WAF green or blue, right? And based on that, it will be pushed installed into that particular routing WAF. Okay. Any question, or is it clear? Okay. So yeah, this is how it works, right? So as we discussed, this green, this green will be advertised. So basically, this 10.1.10.10.1.0 will be advertised, right? Like this type 5 route. So 10.10.1.0/24 WARF ID or VNI is 10,000 because we have configured this, green WARF to VNI mapping, which is 1,000. So it will use that this 10,000 is the VNI. Next hop is 2221. So this is the VTAP IP, right? From which it is generated, and inner destination MAC. So basically this is the MAC of this VTAP, right? System MLAG system ID. So we are using MLAG system ID. Okay. So MLAG system ID will be used to advertise this route, right? To this site, right? And once you receive this route, you will install that into your WAF. So basically it will be installed 10.10.1.0 with VNI 1,000, and next hop is this VTAP IP, and also MAC also is there. Okay. So is it any question? Okay. So let me show, in lab, right? So that it's clear. So this is leaf 1A. Okay. So let's first check show run interface VXLAN 1. Okay. So this is the configuration we need to do, right? This we can just remove this. Let me just remove so that there is no confusion. So interface VXLAN 1. Okay, we'll remove from all, right? So basically I'm removing all the L2 EVPN related config, right? From all these leaf pairs. Okay. Router BGP show active. No VLAN aware, right? We don't need this. This is L3 EVPN. So yeah, we have removed this. So basically now if we check only L3 EVPN, right? So this is the configuration, right? WAF 10 and A, VNI 10, right? So basically this is the WAF 10A, WAF A with VNI 10, right? Okay, so why this command, right? What is the significance of this command? VXLAN virtual router encapsulation MAC address MLAG system ID, right? So basically what this will do, I'll explain you based on the we'll just come discuss on that in few minutes. So basically interface VLAN 110. So these are the two VLANs, right? 110 and 111, which is directly connected into WAF A, right? So WAF A has both the VLANs, SVIs, 110 and 111, right? So, and this is the configuration under BGP. So it's a EVPN overlay. Underlay is OSPF. This is same symmetric setup. So OSPF VTAP to VTAP reachability or loopback to loopback reachability is through OSPF, and also IBGP peer is also OSPF. Okay. So this is the configuration, right? So what we have done is that WAF tenant A, right? Under this WAF, we have route distinguisher and route target and redistribute connected, right? So if we check show IP route WAF, basically for this tenant A, these are the two connected routes, 10.1.10.0, which is SVI 110 and SVI 111. So we have this two connected route, right? And what we will do is, because we have written, configured here, redistribute connected, we will advertise this route in as a type 5 route, right? So basically we will generate route type, IP prefix, IPv4 detail, right? So basically we will generate type 5 route, right? For 10.1.10.0/24, right? This is the RD, and it is route target is our, the route target what we have configured for that WAF, correct? Show run sec BGP. So this is the route target we configured, and this is the RD value. So this is the route target, route distinguisher, tunnel type is VXLAN. So this is our VXLAN, right? Not MPLS data plane. So that's why here it's a VXLAN. And MAC router MAC. So this router MAC is nothing but MLAC system ID. Show MLAC, right? So this is the MAC. So this MAC can be either of this device or MLAC peer, right? Let's check here. It's yeah. So it's of this device because this guy is they are using this as a MLAC system ID. So we are advertising this MAC here in the update, right? As a EVPN router MAC. And VNI is 10. This is WRF to VNI mapping. Now, if we have not configured that, so if we have not configured this command, right? This command basically says that whenever you advertise type 5 route, this MAC address, right, should be MLAC system ID. Whatever MAC address we are advertising, basically MAC address we are saying to in advertisement we are using, that should be MLAC system ID. So basically this MAC address should be MLAC system ID, right? So when this route received here, the MAC corresponding MAC to reach out will be, or basically will be in a source header, inner header will be the system MAC, MLAC system MAC, which is common to both, right? If we don't configure this, then what will happen is that this VTAP out of there are two VTAP pairs, right? VTAP 1 and 2. So VTAP 1 will advertise its own physical MAC, right? Physical MAC, and VTAP 2 will advertise its own physical MAC. So basically when you receive this route at this side, it will have that route, right, to reach 10.10.1.0/24. It will have two ECMP paths. So one is pointing to MAC of the VTAP A and another to pointing to MAC of VTAP B. It will not be, basically it will have two different paths, right? It will show as a two different path instead of showing only one path of MAC system MAC. Okay. So right now, as we can see, show IP route of all, right? As we can see here that this is only one route, right? Only one route with this system MAC, MLAC system MAC of that VTAP 1, right? Basically this, the other side, sorry, other VTAP, correct? And if we further check the next hop, right? Next hop to reach, next hop to 54.5, we see two different paths, spine 1 and spine 2, right? So yeah, this is the difference, and that's why we configure that, right? So that we have only one path and basically same one MAC, and based on that we will forward the traffic to either of that VTAP. Okay, any question if you have not understood?
So Vishal, if we have that other configuration where it's not, we don't have MLAG system ID, through ECMP, it means we kind of send some traffic to VTAP1, some other traffic to VTAP2, right? We kind of balance.
Yes,
right?
yes. Let me show. Yeah. Let me show one. How it will look like, right? So this is how it will look like the other side. So on leaf 2A, if you do show IP route, right, of that particular, you can consider this as a 10.10.12.0, whatever, right? That subnet, it will show reflect like this, right? So it has same destination VTAP, right? Both VTAPs are same. BNI is also same, right? But two different router MAC, right? So one is VTAP leaf 1A router MAC and another is leaf 1B router MAC. So when you send the traffic, you sometime you might add source MAC as this MAC while sending traffic, and a destination MAC, sorry, and sometime you might add this as a destination MAC, and depending on that, basically that VTAP, that traffic will reach to that VTAP. Okay.
So yeah, then after that, what could go wrong next? Because the traffic has still gone.
Yeah, so basically traffic will still go. Let's come back to topology, right? Yeah, so let's say you send the traffic, right, with the leaf 1A and 1B, right? This 1A and 1B. Okay. Now you send traffic to 1B. Okay. Now your inner destination MAC is 1B. 1B inner destination MAC. Inner source MAC is your this guy MAC, right? MAC 2A or whatever, right? 2A. You send this traffic. Obviously, you will encapsulate VXLAN and all that. VTAP source VTAP is 2222. Destination is 2221. So this guy that packet might land on this guy, right? 1A. It decapsulates the packet, it removes all this. It knows that based on VNI, right? It knows that, hey, I have to route this packet into this green WAF, right? Now it checks the destination MAC. That is what 1B, right? See, ultimately it has to send packet directly here, which he knows, right? He can also send. But because destination MAC is 1B, it has to send that packet to 1B, and then 1B will send this here, right? So basically unnecessary you are using this this peer link, right? Because for routing, first traffic has to reach to the destination MAC 1B, and then only it will be sent, right? So yeah, that's only the differences. But if you have system ID, MLEC system ID, right, which is, we can say 1, right, then wherever it lands, that switch will locally route the traffic, right? It don't have to send it to the other guy, right? Yeah. So yeah, that's the difference. But so basically it will still work, but yeah, if you want to make it, yeah, you can just make it, avoid unnecessary utilization of peer link. Okay. Any other questions? So is it clear? Route type, IPv4, IP prefix, IPv4 detail, right? Is this clear? So basically we advertise this route, right? we advertise, where is that route? Route type, IP. Yeah, so we advertise this 10.1.10.0/24 route through EVPN, right, to the spine, right? So we receive this route here. So BGP EVPN route type, right? IP prefix, IPv4 10.1.10.0/24. Okay, IP prefix 10.1.10.0/24 detail, right? So basically from leaf 1A, we will receive this route, right, with next hop as VTEP1 VTEP IP, right? And through this basically, two different VTEP, basically loopback IP addresses, neighborship BGP EVPN, and with route target as 1010, route origin, router MAC, which is MLEX system ID and VNI. And then this again will be advertised to leaf 2A, right? So basically here on leaf 2A, we get this route, EVPN, route type, IP prefix 10.1.10.0/24 detail. So basically we receive this route on leaf 2A, right? The other side of VTEP through from VTEP 1, right? And this is the route target. So based on this route target, we understand that, hey, we have to push this route into this WAF, right? Tenant A WAF. And then this is the MAC. So based on that, we will configure tenant WAF all, right? So basically based on that, we configure that route 10.1.10.0. We received from next hop VTEP T54.3, which is leaf 1A, leaf 1A and B, VNI 10. This is associated with this WRF. And this is the MLEX system ID of VTEP 1, right? And over interface VXLAN 1. So basically when you draft the packet, right, when you receive the packet which you have to send to this subnet host, you will add all your data fields based on this information, right? So when you have to send the packet, you receive packet on leaf 2A, right, from down host, correct? You draft the packet, basically you create the packet, right? So your source MAC is this VTEP MAC, right, which is, let's say, B. Destination MAC is this MAC, right, which you have received. We can say that E8, right, which is nothing but VTEP 1 MAC system, MLEX system ID. Obviously, you will have source IP and destination IP if it is ICMP, right? Source IP and destination IP H1 to H3. So H3 and H1, right? And top of that, you will add VNI, which is nothing but VNI 10 for this WAF. So VNI 10. And then source VTEP IP is your this VTEP IP, which is nothing but 254.5. And destination VTEP IP is VTEP AIP, 1 IP, with 254.3, right? So basically to create the packet, all the information you have in your update or routing table, and how this is updated, that is based on your the route type 5 route you received, right? So based on all this information, you create this route, install this route, and this route is used when you have to send the data traffic, right? Is it clear? Any question? Okay. So yeah, this is how you use this. And if you want to check the packet capture, right, of type 5 route, so this is how it looks like. So you have BGP update message, MP reachability, FSFE. Next stop is 254.3. So this is the VTEP 1 IP address, right, who has advertised this route. NLRI is IP prefix type 5 route, right? RD route distinguisher, ESI is 0 because it's MLAC. Ethernet tag is also 0 because right now we are not, it's only type 5 route, right? It's not L2 EVPN. So there is no VLAN aware or VLAN based bundle. And we are advertising this prefix 10.1.10.0/24 with this VNI, right? This is the WRF to VNI mapping. And if you see here in the same update message, you have this route 10.1.10.0/24. You also advertise another route, this 10.255.1.3/32, right? So that is another route you advertise, and one more is 10.1.11.0/24. So basically in one update, because all these three routes has same next hop, right? So we advertise all the routes, combine all the routes together who has same next hop, and that will be advertised. And along with this extended, basically other attributes, right? So one, that is route target. So we add route target 10:10, route origin, encapsulation VXLAN, and router MAC, right? MLEC system ID MAC, right? So this all information will be advertised, multiple route information, NLRIs, to the other side. Okay. Any question? Okay. So yeah, let me take a pause, and yeah, any question on L3 EVPN? Okay. So basically in type 2 also, right? Type 2 also we send only MAC plus IP information. Basically we advertise host addresses, right? If you remember symmetric type 2 update, we advertise MAC plus IP information, right? MAC plus IP information. And we also install it into BGP EVPN routing into that WAF, right? As a route, if that is symmetric IRB. But that is only /32 route, right? You can't advertise full subnet. You can't advertise /24 subnet using type 2 routing updates. You can just advertise host routes, right? /32 routes. So to advertise /24 full subnet, right? You need to use type 5 update messages. Okay. So purpose of type 2 and type 5 is different, right? Type 2 is just to advertise MAC plus IP information. If it is asymmetric IRB, that information based on that, it will be updated into ARP table if that SVI is local. If that SVI is not present in that VTAP, it will install /32 route, right, into that WAF, right, based on type 2 route. However, type /24 type 5 route is you can advertise any basically any subnet, full subnet, right, to the other side. So that's why this is called L3 EVPN and this is L2 EVPN. Okay. So yeah, this is again, the packet format, route distinguisher, Ethernet segment is 0, tag is 0. In this case, IP address subnet mask and IP address subnet. Gateway is 0. This is what, if you remember, we discussed when we discussed about type 5 router, there was a question, right? So why? So gateway is always 0 in Arista implementation, right? Because we advertise this router MAC, not the gateway of the origin. Okay. So that's why it will be always 0 in Arista implementation. VNI VLAN to WRF mapping, WRF to VNI mapping. So in our case, it was 10, right? So VNI information, route target, which is nothing but 1010 in our case, and MAC address, right, of the MLEC system ID. And tunnel encapsulation is VXLAN in this case. So yeah, this is all information we will advertise. So this is, so basically see, there are different variants of, L3 EVPN you can you can have customer might use. So one is this VTAP has SVI, right? SVI, which we have seen in lab, and subnet 10.10. 10.1.10.0, right? Subnet 10.1.10.0/24. And we have redistribute connected under WAF so that you advertise this, right? So this is one variant, which is what in our lab is, right? We have SVIs and we advertise that prefix is this subnet as a type 5 route. Okay. Another way is, let's say this is a PE router, right? PE router. And this is the customer router, CE, customer edge router, right? So you have this L3 link and even BGP between these two, eBGP, let's say, right? With ISP or PE device, right? This is say ISP. So what, and this is your local subnet, 172.21.1.0/24. So what you will do is you will advertise this subnet over eBGP to this guy, right? PE device or VTAP1. So you have in routing table of this WRF blue. So this interface is in WRF blue, right? So in your WRF blue routing table, you have this subnet, right? 172.21.1.0/24. Next hop is this another router E1 interface towards, right? Now what you will do is you generate. So obviously you have to configure, redistribute, basically this route, right? This route will now you have to, you need to advertise it to type 5 route to other guy, right? So basically you have to advertise this route, right? So you receive eBGP route and then that will be automatically advertised through EVPN type 5 route. So it will be advertised as type 5 route, right? And that will received here. Again, you will install that route into this blue WRF, right? Blue WRF, and then it will be advertised to the tenant or another device, right? So this is how basically another CE device, if there is CE device here through eBGP, right? So this is how it will basically work. So either you have SVI local and you are advertising that SVIs, or you can have eBGP or any peering through which you are receiving any subnet, and that subnet you are advertising using type 5 routes, right? So it can be either way. Means there are different implementation depending on implementation. Most of the time you will see, this tenant is connected, different tenants is connected to this guy, and this is acting as a PE or basically PE device. Is it clear? Any question? Okay. So this is how it looks like, right? So basically this 172.21.1.0 is directly connected route, right? Here. Yes. You advertise this route through BGP to this guy. So your configuration will be under router BGP, right? You have IP WRF blue configured, right? You have RD and RT configured, right? You also have neighborship, BGP neighborship with this guy. So this BGP neighborship is configured under here. So BGP neighbor, right? Neighbor under this WRF, and this the other guy neighborship, right? That is configured here. So basically you receive this route under this WRF, right? So basically this route is received here locally under this WRF, blue WRF. You can generate type 5 route for this route and advertise type 5 route to this guy. So you receive that 172.21.1.0 type 5 route, you install it into WRF blue, and next hop is VTAP1, right? Here 21.1.0 next hop is Ethernet 1, this guy, right? So this is how, end to end this route will be advertised. Okay. Any question? Yeah.
Sorry, Vishal, I think I got lost in this scenario here because I'm wondering,
Yeah.
because this one because previously there's a redistribute connected, which is making us advertise the type 5. So in
Yes.
VTEP 1, how are we generating type 5? Once, because the route is now it's learned by eBGP, right?
Yes. Yes. Okay. So basically, okay. So what we discuss or what we have in lab is this, right? We have SVI here, right?
Yeah.
And let's say SVI has this IP address, right? VLAN,
Yeah,
any
yeah.
VLAN 11, and this
Yeah.
IP address configure. So because of redistribute connected, we will advertise this type 5 route, right?
Yeah.
That
Yeah.
is how we are doing in lab. Now in this, let's say you don't have SVI here, right? There is no SVI here, right? What you do is there is a peer CE device, right? Customer edge. So that device is advertising you. Okay, so what will be the config change, right? Under WAF. So under router BGP, right? Router BGP, we have WAF blue, right? Configuration, WAF blue. And under that, we have RD and RT configured and redistribute connected. So this is our normal configuration, right? Extra configuration for to support this is we also have to configure neighbor, right? This neighbor. So basically BGP neighborship is under this WAF blue. Okay, this neighborship. So we will configure that neighbor 192.168.21.2. Let's say this side is 2, right? So we will bring up BGP neighborship, normal BGP neighborship between these two, right?
Yeah.
So now what will happen? You advertise this prefix through BGP neighborship here to this guy. So you install this through this normal BGP peering, right? Not EVPN, normal BGP peering. You receive this route and install into your router WAF blue routing table, right? 172.21.1.0. So you have installed it. Now, because so this is BGP route you received into this WAF, right? And so eBGP to eBGP route is advertised, right? There is nothing basically we don't have to do anything, right? So what it will do, as soon as you learn this route, you advertise that route, type 5 route, right? You create type 5 route of it, right? And you advertise it to the other VTAP. And what are the information in type 5 route? That hey, to reach 172.1.1.0/24, next hop is the VTAP 1, right? Next hop is VTAP 1, VNI is 10, right? This WRF to VNI mapping, route target is 10:10, and MAC, what you have to use is MLEC system ID MAC, right? System MAC of VTAP 1. So you advertise type 5 route with all this information. And based on that, this guy will basically EVPN table will receive this route. Based on route target, it will install that route into WRF blue. So this is the route you will see in WRF blue 172.21.10/24 pointing to VTAP 1. Okay. Is it clear?
Yeah, so for VTEP 1, this neighbor command under VRF blue, is that the same command you're using to form the neighborship with the CE, or there's another?
Yeah, this is the neighborship
command?
with CE. This is the neighborship with CE. This one.
Okay.
Yeah. Yeah, maybe I'll do one thing. We'll have lab with this scenario, right? Next time in next session. Okay, so that it's clear, because customer, you will see L3 EVPN, right? With customer L3 VPN, they will be using this only, right? Where you have BGP neighborship, and from that BGP neighborship, you receive route and then advertise as type 5. Okay. So yeah, we'll discuss, we'll have that lab. Okay. Any other question? Okay.
A lot to take in. It's just
okay.
I don't know.
Okay, so do you have any other means? Is there any doubt?
No, not for me for this one. No.
Okay, no problem.
So of course, for the you can always use route maps to also filter out what you want to advertise and what you don't, right?
Sorry.
You always can use route maps to identify what you
Yes,
want
yes,
to
yes. Yeah,
fund and what you don't.
we always, and we should use, right? So
Mm.
otherwise we might end up in routing loop. So basically, yeah, we should use route maps. Okay. Okay, so let's see the configuration, right? So basically, first of all, you have to, on this VTAP, you have to configure the WAF, right? WAF blue, this VLAN under WAF blue, an IP address, and routing for that WAF blue, you have to enable it, right? So this is the one part of the configuration. Another is you have to configure this, right? Router under router BGP, you have to configure WAF blue, right? This is for L3 EVPN configuration. So this is the what I was saying. See, you already have under WAF blue, you have RD and RT, right? What we configure, right? Which is here. So we already configure this too, right? Under WAF, correct? RD and RT, and redistribute connected. The extra config, right, is you need to also have neighborship, eBGP neighborship between with this CE device, right? CE device. And that's what you configure here. Okay. So on top of this configuration, RDRT, you also add this neighbor configuration. So basically, what you are saying is in WAF blue, you have BGP neighborship from where you receive the route, and then that route you advertise as a type 5 route. Okay.
So in this scenario here, the redistribute connected under VAF blue, do we have any connected routes in VAF blue, or we are advertising eBGP routes?
So definitely we are advertising this routes eBGP, which we receive for this subnet, right? Underneath this, that's what we are advertising. Redistribute connected, if we want to advertise any directly connected route of, if there is any SVI's local under WAF blue, if we want to advertise that as well, then we need redistribute connected. Otherwise, we don't need this.
Okay. Because I'm wondering, so which command, if missing, the type 5 will not be generated?
Okay, so type 5 will be, so okay, so if you have this neighborship command, right? Neighborship with this, the whatever route you receive here through this neighbor into this WAF, that will be advertised as type 5 route. For that, you don't need redistribute connected. Okay. Why you need redistribute connected? If you want to advertise SVIs in this WAF, right? Also as a route, as type 5 route, then only you need this redistribute connected. Okay. Which we have here, right? So that's why we are advertising SVIs, right? Directly connected SVIs routes, this two.
Okay.
But if we don't need that, we can remove this redistribute connected. That is not needed, provided you want to just advertise routes you received from CE devices. And that's what the configuration you also will see with customer most of the time in these scenarios.
Yeah.
Right.
Okay.
Yeah. And then further configuration is, yeah, obvious, SVI, WRF blue routing, and then VLAN to WRF to VNI mapping, right? So this is another config you need to configure on top of what we already have, right? We under VXLAN. And yeah, so this is how it looks like, right? So this is the overall config of WRF. Again, this is depend on whether you want to redistribute directly connected routes or not, right? So what you do is you have another CE device here under which you have route 172.21, whatever, right? That subnet you receive through BGP, through this BGP neighborship, and then you convert that into type 5 route and advertise that further to VTAP2. Okay. Okay, I think that's what we have today. So if we want, do you guys want to check anything on leaf devices or anything on this, or it's not clear? So for type 5, you don't need to, you don't need IMAT or flood list and populated VXLAN flood list and all that, right? You just need type 5 routes to, advertise type 5 route.
But how do we still need to know which VTEPs to advertise to, right?
Yeah. So basically,
So if you do
okay.
not have
So
the
okay.
flood
You
list,
mean to say, okay, which VTEP you have to advertise that route, right? Type 5.
yeah,
No.
yeah.
So basically, so what you are doing is you just have BGP EVPN neighborship to spine, right? So basically what you do, let's go through this, right? So basically,
yes.
yeah,
Send it to
show
spine.
IP interface brief, right? So you have, let's say, this VLAN 110, right? 10.1.10.1/0/24. This is the subnet, right?
Yeah.
You can generate type 5 route for this. Show BGP EVPN, right? Route type, IP prefix 10.1.10.0/24 detail, right? So you generated type 5 route because you have configured redistribute connected under BGP EVPN, right? So you generate this route, right? And advertise to all your neighbors, spine 1 and spine 2. That's it, right? You don't need to know what are the VTEPs, right? You just advertise this to type 5 route to both the spines, right? Now let's go to the spine. So basically you advertise this, right? Show BGP EVPN, show BGP neighbor, right? This guy, EVPN advertise routes, right? So basically you have advertised this prefix route 10.1.10.0, right? To the spine, right?
Yeah.
Now let's go to the spine. Show BGP EVPN route type IP prefix, right? 10.1.10.0.0/24 detail. So you received this route from your leaf 1A, and also 1B also will advertise. So leaf 1B. So you received this route update, right? To route update from leaf 1A and 1B, right?
Yeah.
Now check the show BGP EVPN summary, right? So now it has EVPN neighborship with leaf 1A, 1B, 2A, 2B. You already receiving route from 1A, one route, and 1B route, right? So you will not again advertise to them. So you will advertise this route to 2A and 2B, right? So basically, as soon as spine receives this route from 1A and 1B, it will forward that route to 2A and 2B, right? So show BGP neighbor, right? This is 2A or 2A EVPN advertise route, right? So basically it is advertising 10.1.10.0, which it has received from 3 and 4, right? So other basically VTEP 3, right? Leaf 1, and then it will advertise to 2A and 2B, and then 2A and 2B will receive that, right? So 2A and 2B will receive this EVPN summary. So BGP neighbor, right, from spine 1, EVPN receive routes, right? So it receives this route 10.1.10.0/24, and based on that, it will add it into its WAF, right? WAF table. Does this make sense? Is it clear?
Yeah.
Yeah. So basically, your spine will work as a route server, right? In this case, which will just receive all the routes from the leaves, from the one pair of leaves, and advertise to other leaves. Okay.
Yeah. So, and on the route that we install there, the local interface VX1, how's that one? How are we gonna use that one later?
Which one? This one?
Yeah.
Yeah. So this is basically, it says that, hey, if you want to read to this subnet, right, you have to encapsulate the packet.
Okay.
Right. So it's not local, right? So you have to encapsulate the packet, and to encapsulate the packet, all the information we need, right? That is the basically destination MAC is this, VNI use this, destination VTAP is this. So you get all the information from here.
Okay.
Okay.
Yeah.
Okay. Any other questions? Any doubts? Okay. Fine. So I think, yeah, let's do one. We'll have one lab, right, with this type of scenario, right, where we have BGP neighborship, right, with the client C devices. So we'll have that lab next week. And apart from that, I don't have anything, right? So just we can discuss if you have any doubts throughout, symmetric, asymmetric, right? Anything, any doubts you have, or you want me to cover any other troubleshooting or anything you want, right? Anything. Basically, if you want to do troubleshooting scenario for particular symmetric or something, so that we can cover. So let me know. Okay. And based on that, we'll definitely do this lab, EVPN, L3 EVPN C. But other than that, if you want anything, let me know. Okay.
Thanks.
Okay. Yeah.